Okay, so today we're going to talk about the International System of Units, the SI, International System of Units. What is the SI, the International System of Units? It is the modern metric system and the global standard for measurement, which is established to ensure worldwide consistency and comparability in science, basically. Um, its historical context or start is located in the French Revolution. We've made in class an activity about this, and if you didn't come, you can ask for the worksheet and I'll give it to you. But in this video, we'll only be covering what's most fundamental about the SI, and we're not going to enter in those historical things. So we'll only be covering two very important things about the international system. We're going to be covering the base units, and we're going to be covering the derived units. What is this? Well, basically, it's known that only talking about 7 different base units, we can form everything or every other property that we can measure in matter. These 7 base units are length, mass, time, electric current, temperature, amount of substance, and luminous intensity. So knowing those 7 properties and assigning those 7 properties 7 units to measure those properties, we can then create all the other properties that we can measure in different objects. We're not going to talk about all the derived units possible because there are really infinite. There are infinite properties that we can think of. Maybe not infinite, but too many to count on this video. And they basically come from these base units. What is a derived unit? A derived unit is a unit that can be compounded with base units. For example, speed is a derived unit. Why? Because it comes from length and it comes from time. The speed is measured in meters per second, which is 2 base units. So I was saying, sorry, I had an interruption. So I was saying that speed is a derived unit because it comes from 2 different base units, which are length and time. Speed is measured in meters per second. Other derived units that we can think about are, for example, area or surface, which is measured in meters squared, which is basically 2 length units, so 2 base units. This is also true for volume, meters cubic. This is also true for force, which is measured in newtons, and it's formed from kilograms, so mass units, is from meters, so length units, and it also comes from squared seconds, so time units. So basically all other units, apart from the 7 base units we've said, length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity, are derived units, and we can think of many of these. In order to understand this, or to use this to measure and to learn more about the world around us, we need to learn these base units and the units that we use to measure each of these quantities. So I'll be talking briefly about these units and these quantities, these properties, and their units. Now with the table in front of us. So this is the table for the base units of the International System of Units, and here we can see that we have the 7 base units: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Each of these properties, each of these quantities is is a property of matter we can measure. We can measure length, and we measure it in meters. We can measure mass, and we measure it in kilograms. There are some of these quantities that maybe are not so common in everyday life. For example, electric current, amperes, you probably haven't heard of it. Temperature, you've probably also didn't heard about Kelvin. You probably heard about Celsius degrees. But we will talk about Kelvin in next videos, so you understand why do we use in the international system, why do we use Kelvin to talk about temperature. Also, amount of substance, mole, what is this? We're also going to cover this in this course. And finally, candela, about with luminous intensity. So these four are probably quite new to you, but you probably know length, mass, and time, which are the most common in everyday life units that we use in an everyday life. So this table is important, is fundamental to learn it in order to be able to actually measure in science. So in the next exam that we're going to be covering, this unit 1, by the next exam, you should be able to fill a table like this. You should learn this table by heart. You should learn what the name of the quantities are, what the name of the 7 base quantities are, what are the units, what are the symbols, and an example. You should be able to put an example for each of this quantity. So for length would be the distance between 2 points, for mass would be the weight of an object, measured in mass. Weight of an object is actually a bad example. I think I should change this. I should change this, sorry. Because weight of an object is not correct. This should be something like mass of an object. Mass of an object. Because weight and mass are different things. We'll talk about this in later videos. Time could be used to talk about the duration of an event. That's okay. Electric current would be the flow of electric charge. Temperature would be thermal energy. How hot, how cold is something. Amount of substance is the number of particles in an object. And finally, luminous intensity would be the brightness of light source. For example, the brightness of a light bulb. So, as I said, examples are actually not going to enter in the exam, but it could be okay to understand them, so you know if you actually understand them or not. But which is very important for the exam, is to know the quantities, the unit names, and the symbols. Not only for the base units, but also for some derived units. We're going to see one table now. So this is a table for the derived units, for some derived units, sorry. We've got here force, pressure, energy, electric charge, area, volume, velocity, acceleration, and density. So these are some examples, but as I said, there are many derived units. Do we need to know all derived units? Well, no, that's impossible. I don't even know all derived units that exists. So what do we need to know? We're going to start with this small table. And as we follow the course, we will learn new quantities, new derived units, new derived quantities or derived properties that we will be studying. So what do we need to learn for this exam? The name of the quantity, the name of the property, the name of the magnitude, which all of those are synonyms: quantity, magnitude, property. We also need to know the unit name in which they are measured, and we need to know the unit symbol. You probably didn't heard about most of these quantities yourself. Maybe you've heard about force, but it's very unlikely that you've heard that it's measured in newtons. You've probably heard about pressure, but you probably didn't hear about Pascal, and so on. So we need to learn the international system units for the quantities, for these derived quantities at least. We will be using them throughout the course, and so we will be learning more about this in the future. And with this, we finished the video. We've covered basically the International System of Units. We've talked about the base units and derived units. And why are they important? It's because we all need to use same units, same ideas to communicate with everyone around the globe. Thanks for watching this video. I hope it was useful for you, and see you on the next one. Goodbye.